Good evening, one and all. I welcome you all in this academic forum session, which we have planned on igniting the joy of engineering. This is our sixth session. I request Dr. Sanjay Goyal, who actually initiated this igniting the joy of engineering, ignited all of us to prepare good presentations on the courses which we have delivered. Over to you, sir. Sanjay, sir.
Thank you. Good evening to all and welcome to this sixth session in this series. And I hope that we will have many more sessions in this series in next few months. There has been some gap in between and I'm sorry for that. I should have been talking to more colleagues to make these sessions. And Devika has been ready for quite some time. The fault is on our part.
Yeah, we could.
Okay. Yeah. So this is a very, very important session today. The joy of engineering, as we all know, is basically in building things, right? Building things on solid foundations of science and maths and understanding of the user's needs and of the societal constraints, the government regulations, etc. And of course, within the constraints of the economics and law. Okay. So this course, automation project, is a compulsory course for all our engineering students. This is one of the unique aspects of our engineering program. Okay, that in a third year, all the engineering students, irrespective of their branch, again come together. Usually what happens at most of the places is that after first year, they separate out, never to meet except in the cafeteria or in the cultural and the sports venues. Okay, so this program, this course in third year is a common course for all the branches, simultaneously delivered to all of them. And this builds upon previous common courses. So the journey starts in first year with a course, Fundamentals of Automation Engineering, which is a year-long course now, both in semester 1 and semester 2, 3 credits each. Then where we lay the foundations of this particular course. Okay, and then we move on to do a course which we should have done, or maybe we could have included content of that course within this seminar itself, is engineering measurements and machines in second year. That again is a common course. That is again a USP of our engineering program. All engineering students together do that course, and I request Pushpendra, etc., and the other colleagues who teach that course to prepare a session on that course also in next few weeks or months. Okay. So that course builds foundations for this course. Again, I mean, it strengthens the foundations for this course based on what they have done in the first year. And then in third year, they do a course, a sister course on IoT, and they do this course, automation project. So these 6 credits in first year, 5 credits in second year, or 4 credits in second year, and 4 credits in third year, which are common to all of the students of all engineering branches. So 6 plus 8, 14 credits are given to all engineering students. And together, this journey is about building automated systems using various electronic technologies, software, using various sensors, using a variety of actuators that they study in second year and also get introduced in the first year. So this is a journey, a 3-year-long journey, and this course is going on very well. It was more exciting to do it when we were able to do it on campus, but even when we have not been able to meet on campus, even then the degradation has not been much. In fact, the quality improvement, quality has further improved, maybe not as much as it could have if we were there on the campus, but still it is going on well. They are still building systems, interesting applications. They are conceiving, students are conceiving interesting applications for applying automation techniques to a variety of application domains, and joining hands and building very interesting systems. And so this whole series is quite a USP of our engineering program. All these 14 credits are quite a USP of our BTech program, and we hope that in the time to come, we will only strengthen it. And then this is followed up by more electives in the industrial IoT area and some other courses that we deliver in this series. Okay, so I welcome the team that designs this course, delivers this course, evaluates students, and thinks of interesting projects, thinks of interesting ways, interesting tools that can be given to the students, always wanting to add things in the laboratories. So the corner laboratory in our technology block is the place where a lot of these things get tried out, and hope that laboratory becomes stronger and stronger in times to come, and it grows in size, because we would want that every engineering student uses that laboratory to build this kind of system. Okay, so over to the team, Devika, Gustavo, Divanshu, and HP.
Thank you, sir. Thank you. So, good evening, everyone. We are going to start with this igniting the joy of engineering with IoT and automation projects. And this is a team of 4 faculty members: Divanshu, Professor Gustavo, Hanuman, and I'm involved in this. And we have today just 20 slides with us, but then we have some exciting demonstrations and we have student perceptions with us. With this, I will now request Divanshu to start with the course, about the course Introduction to IoT.
Thank you, ma'am. Thank you, sir. So good evening to all. So as sir and ma'am told that this semester we had the introduction to IoT for the first 2 months, let's say 8 weeks, and then student has to do the projects in the coming next 2 months. Okay. So first we have gave the introduction to IoT course, and in this particular course we have asked them to complete these many learning outcomes. So they have to work on the analog and digital sensors. They have to understand the programming, how these sensors can be connected with the microcontroller. Here microcontroller we have used, one is the Node MCU because we have mixed kind of students, and we have also used the Raspberry Pi. And once they have connected, they had seen the data is coming from the sensor. They had tried to implement, they had tried to actuate some actuators like the relays and the other LEDs, buzzers. And after once they are comfortable with this one, so now they have to upload this data on the servers. So we have also worked on the Blink app and the ThingSpeak server. So these things we have done in this course. So these students have to complete these learning outcomes. Next slide, ma'am. So preparation of the module, like because the students are in the online mode, so we have asked them to purchase the Node MCU kit. It is not very costly, and if those who are nearby our university, they can get it from the university. And for the Raspberry Pi, we have arranged the method that they can work in the distance mode and online mode. They can connect with our laboratory. Next slide, ma'am. So before moving ahead, so before working on the practical things, so we have to ask them for the theory concept. So I took the lectures on the IoT fundamentals, sensors, actuators, their working, the microcontroller, their architecture, the how the software will be installed, how the basic programming, they all know the basic Python programming, and then they have to display, they have to connect the sensor. So all these things in advance, we have asked them uh, to to learn the theoretical concepts. Next slide, ma'am.
1 second. 1 second, it's
Yes, ma'am.
stuck. I need to just stop sharing and share again. 1 minute. Yes.
Okay. So after once they have learned about the theoretical concept, then they have worked in the lab. So we have done the hands-on session. So now every student, they were having their own microcontroller and starting the node MCU. And they were doing the programming, they're blinking the different LED patterns. They are working on the switches, how to control the LEDs so that later on they can use it in their projects. How to use the LCD display and how to work with the analog and the digital sensors so that they can work in the project and they can make some good projects. Okay, and for the cloud, we have used the Blink app. 1 minute, ma'am. Uh, so they have worked on the Blink app. On also like Blink app, they are giving the alert on the mail. They can just generate a Twitter message. So let's suppose if today my plant has given the rose plant, okay. So then I want to share it with my friend. So what I can do, I can just share this message over my Twitter. So this kind of activities we have done, like they have uploaded the data on the ThingSpeak server and they have visualized the dashboard. Also, they have done programming for the IoT applications. And at the same time, we have asked the student to think about the project because that will be coming in their next course. That was the automation project. Next slide, ma'am. So these were the activity snapshot. Like here we can see, like let's say the sensor LM35 here. Then they have connected, they have uploaded the data on the Blink app. From there they can control, they can send the message to the mail, they can alert. Also, like they can upload the data on the ThingSpeak server, they can analyze the values, they can put the switch conditions, if else condition to just glow the LEDs and all. Also the different sensors. Next slide, ma'am.
Thank you,
So,
Divyanshu.
yes, ma'am.
So once the students have spent some 7-8 weeks and they've done a lot of activities, they've learned the fundamental concepts of Internet of Things, we then ask them to make teams in which there could be maximum 4 students in a team. A minimum could be 1 also. And then they identify the project which they have to do, and while doing this project they have to keep in their mind the following learning outcomes which are listed here. So they have to identify the microcontroller or the system on chip which they have to work upon. They have to identify any other tools required. They have to use one of the standard data communication or IoT protocols which has already been explained to them in the introductory course. They are also familiar by now with cloud servers, and they are now able to decide which cloud service is required and what kind of analytical techniques they would be needing on the cloud. Also, we encourage them to use some signal processing either at the edge or at the cloud. And then we sensitize them to the sustainability goals, the UN sustainability goals, where we tell them one of these sustainability goals should be there incorporated in the project, where they either conserve bandwidth or energy or even try to minimize the cost of the project. We have many projects, but we have just picked up few of them here, and I'll be explaining few of them. So this is one project where ECG monitoring was done using wireless sensor, and we can see here node MCU being used, and the ECG graph is shown here, which is a real-time graph which has been captured in our health center. And in this project, the student could do some signal processing to remove the noise from the ECG signal. Data encryption and decryption was done before sending the data through the email. A new type of clouds platform, UBDots, was used, and the student also could do some sensor calibration. Since the student was working alone, Khushbu, who's a PhD scholar, could also join with him and was able to help him out. Another project which has in fact been shortlisted at IEEE Innovation Challenge on 16th of January. This was by IIT Mumbai, and it is in the top 14. The reason being we need to make it little more compact. So this is a woman safety device where there is a button, and a woman may carry this in a purse, and whenever there is a panic, if she presses the button, this device has got a GSM sensor as well as a GPS sensor. So it is able to send the location whenever the person is in danger on a mobile app, as well as send a SOS message saying that the person needs help. Another project which was very interesting is this was a first year project where students had made a material movement system. You can see here this is a conveyor belt, and what they did in their fifth semester was that they converted this conveyor belt into an IoT project. So they put some sensors on this. They had a dust sensor and they had a temperature sensor, and they could upload this data on the cloud, and from the cloud with the sufficient data they have now done an analysis where they have used support vector machines, and they could predict whether there is a possibility of fire taking place. We have also now started using a new type of board, which is NVIDIA Jetson board. I'm grateful to Professor Goyal for that, because we were really after him that if he allows us and he could buy few 2-3 boards for us. So this project is on the Jetson board, where students have used pre-trained mobile net, and then they could do some object detection. I would now request HP sir to continue from here and explain some more projects.
Thank you, ma'am. Good afternoon to all. So in this automation project, me and Divanshu sir mentored the B section students, and around 13 projects developed by the students they under our mentorship. So out of those, this project is the attendance marking system through face scanning. So generally, when we take the attendance in class, there the amount of time is lost, and there is the chance of the proxy. So with the use of this system, we can take the attendance within a few seconds. Here, students just take the image of the class, and then use of with the open CV library and face recognition library. They analyze, they do the image processing and compare the photograph of the image with their existing data and generate the CSV file. And the CSV file show which students are present and which students are absent, which is showing here. Next slide, please. The second project developed by the student is the wireless smart power switch. So in this purpose of this project is to create the wireless switchboard that should be controlled remotely through the mobile app or through some other applications. The other is the device control to switch should be controlled physically. So the position of the device should be updated on the mobile app there. In this, we have used the 3 modules. One is the mobile app. Second, the transmitter, and third one is the receiver switch. So through mobile app, we give the command to operate the device, and this transmitter which connected to the mobile app through Wi-Fi collect the signal and is supplied to the receiver, so it can control the appliance independently. Here one particular thing is students are using the Zigbee. So through Zigbee they can control the number of appliances. In generally, the microcontroller itself has the number of output pins. There are the limitation of the output pins. So with the use of this Zigbee, they can control the different appliances from a remote locations. Next slide, please. Third one project is the IoT enabled advanced security system. Here we can control the security to any buildings or block. So student here they are using this camera, the IR sensor. From IR sensor they collect any person is there, and with that the camera is switched on. It collect the image, and that image is processed through the image processing, and which recognize the face. Either the face is recognized or not. Just like the picture is showing here, the depend which image is identified, and so the person is there, gate is open. If the image is not identified, then it show the error and gate is not open. So in that situation, there is a chance the person can apply the speech password, and here the speech processing is there, and through speech processing, if the speech is identified, then it open the gate. So by 2 layer we can control, we provide the security to the system there. Next slide, please. Third project is the air quality monitoring system. We collect the data through MQ135 sensor and BME280 sensor, where we monitor temperature, pressure, humidity, and air quality, which we upload on the cloud, which is showing how these values are changes. And also we see the values on the display there. Next slide, please. The next project is the IoT-based gymnasium. The purpose of this one is to posture the person, to tracking the posture of the person and identify the face. And with this, we can automatically detect the gymnasium member exciting in the gymnasium through the face recognition, track their posture and notify them if it is incorrect. Keep the record of the exercise they are doing and notify them if they are over exerting themselves. This also track the calories of the burn during the period. Thank you, ma'am. And now over to Gustavo, sir.
Hello. I am audible. Yes.
Yeah.
Yes, sir.
Okay. So after all these projects, which you can see in this slide, our some little sketch of our setup for the Industrial IoT course. This course is an elective course, in fact, and because the Industrial IoT is having many different constraints and requirements if you compare to the general requirements that you can consider for the consumer IoT type of projects. So when I came here in 2018, we started trying to set up this this lab, and since 2018, today we can say that we have this unique setup of elements that I will not explain. What we do in this course is we are going to explain all these elements in details. Devika, please. So now that we have soon we will have this conference on education, and you know that we have been doing some innovation in engineering education itself. So I would like to just to give you a glimpse of what is different, in our opinion, of the approach that we follow for this course. What we do a little bit is we start by explaining the layers of the IoT industrial stack. And then, please next. In this stack, we are going to define some different type of elements like sensors, actuators, some devices, and protocols and brokers. Then, if you have seen all this complexity, we are going to take subsystem. Each subsystem, we are going to explain in detail. We are going to in depth in each of these elements, like sensors, protocols, actuators, and devices. And you can see it's like a puzzle. We are like building this puzzle, and each of these elements, we are going to explain how to interconnect, how to connect all these elements. And at the end, we are able to, at the end of this course, the students are able to understand and see all the complexity in the industrial IoT level. Okay, next, please. So the basic tool that we are using in this course is Node-RED. That is a tool to develop in a very easily way, in a graphical way, in low code, okay? For people that maybe they are not experts in programming, so that we can explain how to connect and how to develop IoT applications by using this type of symbols. Next, please. So if you want more information about this, because we don't have time to explain all the details, we have published this book chapter that is available open access on the internet. If you Google teaching IoT, this link will come, and you can read more about this. Okay, so this is all from my side.
Thank you, team. I would also like to acknowledge AIC JKLU. This industrial IoT setup was taken with their help, as well as we took some purchased some Raspberry Pi boards with their help. I'm also grateful to my own Institute of Engineering, especially to the director for this NVIDIA Jetson boards. With this, we are done with our presentation, and now I would request Divanshu to call upon the students and show some of their projects.
Yes, thank you, ma'am. So first, I would like to call Anshu. Anshu, are you there?
Yes, sir. Good afternoon, sir.
Okay, good afternoon. So Anshu, I am just sharing your video, right? So we can discuss on that. 1 second, please.
Okay. So good afternoon, everyone. So the project which I created along with my group members, Anurag Jha, Amol Bhardwaj, and Kshitij Jain. So the project was basically women's safety device, which also recently got ranked in top 14 in Aakar competition organized by IEEE in collaboration with IIT Bombay. So basically, this project aimed at designing IoT-based safety device that relies on providing security to women by pushing the button. See, like here, when the button is pushed, so a message, SOS message will be generated and will be shown to their Blink application. From there they can find the location of particular woman or a person which is using this device, and also the device can be connected by alerting parents, close friends, relatives via SMS or email, and also nearby police station. So here we used Blink app to track the location. uh, Basically, the challenges, the what was the most challenge by making this in this project was the GPS was not taking signals at first, because the GPS was not such a strong. We have to go out in sunlight for several hours, or we were waiting for several minutes, and uh, till the day end also sometimes we faced problem by the location was not received. But eventually it when we connected it through different device, like first we were using Arduino, then we shifted to Node MCU, and then it basically took the signals. And like you can see here, the message was provided, and by clicking on that message, it will particularly go on the Blink app, open the map location by latitude and longitude. So for future scope, we can make this little device portable by using smaller and stronger GPS and converting whole circuit into small gadgets, such that smart band or something which anyone can wear and like move. If they feel any emergency situation, they can just use a fingerprint sensor or something, and the location will be sent to the respected numbers which are registered. So that was all for this project.
Yes, thank you, Anshu. Okay, next I would like to call this Prasan or Chirag. Are you there? Prasan or Chirag?
Yes, sir, I'm there.
Okay.
It's the IoT-based gym exercise tracking system, and the group members are Prasan Chandak, Ayush Mehta, Sanjeevani Agrawal, and me, Chirag Agrawal. So the objective of our gym management system is to use posture detection to track, so that the user don't have to scan with mobile or carry.
Prasan, you can talk to us. Chirag, are you there?
Yes, sir. I can share it.
Yes.
Can I share
You
screen,
can
sir?
talk to us. Yeah. Screen is shared.
So-
You can talk your experience.
Sir, so firstly, I would like to introduce why I have developed this project. So by saying that, I can what is the current solution to this problem? What the user have to do if they have to track their exercises? So what they will have to do, they will either have to carry a ID or their mobile phone, and then while they are doing workout, they have to scan their device so that they can be tracked. But what we did was we just use Raspberry Pi cameras, and if we install them on machines, So whenever the user goes onto machine, the camera would get activated. The face detection, as you can see, my face get detected. So my name is Agrawal. There's a specific ID on behalf of my name. So as my name gets tracked, now my posture gets tracked, starts getting tracked. So what we did was we are tracking the 33 points of a human body joint system. So these red dots on the screen that you can see are the joints. So we are calculating the angles of these joints, and by calculating these joints, we can track almost any exercises that the user is doing. So they don't need to specify that what exercise they are doing. It is fully automated. So to make this an extent, we have made a bicep counter. So as soon as I am doing doing this, so these 3 joints of my gets tracked, and whenever the angle goes below 30, it means that my hand is up, and it goes above 160, that means my angle is 160. So I have done a 1 bicep rep that gets on the server updated, and this further gets automatically tracked, and this further gets we can use this to count the calories burned, to maintain their diet, and this can be used to track their progress along with friends, and it will be fully automated without any manual task. Thank you.
Thank you, Chirag. And next, I would like to call Raghav or Spurs. Are you there?
Yes, sir.
Okay, 1 minute. Raghav, you can talk to us.
Okay, thank you, sir. Good afternoon, all. So the title of
the person is like Spurs, but right now we are talking with the Raghav. Yes, Raghav.
Yeah. So the title of this project is the Smart Connected Switch. So this is a wireless network where these switches are connected to a master switch, and that master switch is then connected to an application. So the complete system can be divided into 2 states: the physical state and the virtual state. The virtual state is the application. So the job of the master switch is to listen to the state changes. So if the physical state changes, it listens to the state change and then passes on that change to the application. And same is done from the application to the network. So the switches are connected through Zigbee protocol because it is power efficient, and the number of devices that can be engaged in the network are more, and the data transfer speeds are also more than Wi-Fi. And the master node is connected to the application from Wi-Fi, so that you can control your devices from any geographic location. So currently we are constrained by the number of digital input output pin from the microcontroller, but Zigbee protocol does not constrain us on the number of devices. So currently this is a wireless connected smart switch. For future plans, we can what we can do is we can monitor the electricity consumption, and we can also automate some processes like some devices, like when to turn on the refrigerator or turn off, like you can turn off your Wi-Fi if it is connected to this network at nights, because the consumption is less. So this is the complete our complete project. Thank you.
Yes, thank you, Raghav. Okay, so next I would like to call the Divanshu group. So maybe like Avnish or Divanshu, anyone?
Yes, sir.
Okay, so I'm just sharing your project. Yes, please.
So here in this attendance marking system, we try to automate the attendance marking process. So we observed that when the teacher is taking attendance in an offline class, it takes a lot of time, and there can also be a chance of proxies. So we tried to make a system where we can click the photo and then mark the attendance of the whole class. We observed that for the ID card of each student, we already have the photograph of all the students in a database. So we use that kind of database, and then based upon that, we applied a facial recognition algorithm using OpenCV. So here we have made a simple UI on which on clicking the button and showing the camera onto the class, the camera will take the photo of the entire class, given that face of each student is visible. Then the algorithm will run through all the faces, identify them, and then match it with the faces in the database. If it manages to, if there is any match, then the attendance of that student will be marked in a CSV. We have also taken into account if the student is absent, he will be marked absent. And if there is a new admission in the college, then all the previous attendance will be marked as nil.
Okay, thank you, Divyansh. So thank you all the students, and I hope that you all have done good work in the projects. So now over to Gustavo sir. Gustavo sir.
So here, just to introduce the how it is possible in this pandemic times, let's say, to work and with all these IoT projects, etc., and all this. So I would like to show you just an example, because what happened is that we are trying to, okay, so maybe they don't have, students will, obviously, they don't have the hardware and the equipment and the lab, the instruments in their homes, but we can always try to provide them access to any device, any machine that we have on campus. So just to show you this, I would like, if Divanshu, can you please share your screen? So in this case, you can see
Yes, sir.
that I have in my office this machine or this thing where this is a ball and bean system that we have designed this semester also. And Divanshu is today working from home, and we will try to show you. If you see here in in this machine, he will try to control using this dashboard that is running on IBM Cloud. So Divanshu, can you please try to?
Divanshu needs to zoom out a little bit because we are only seeing, I think, a big dashboard. You need to zoom in fact, reduce a little bit.
It cannot be go further.
Okay.
So if you see here in the ball that is here, Divanshu will try to, if you see, it will go up, or maybe it will go here. So yes, please, Divanshu,
yes.
can you try
so here
to?
We can see like Gustavo sir's screen. Okay, and the bar is there, the lift is there. So as I press this switch, this lift will go a little bit up. Okay, so we can control the devices, right?
Yes.
From distance. So here you can see switch on. So it just goes up and the ball turn up. Right?
Yeah.
Again, one more time. Gustavo sir, one more time, please.
Yes,
Okay.
I will do.
Okay, so now we can see the ball is stable. Okay, now I'm just switching on from my home. So we can see the lift will go up. Yes.
So that way we can, students, they can.
Divanshu,
Yes.
Divanshu and Gustavo,
Yes,
what you demonstrated was only the dashboard. The device on Gustavo's table was not visible in this demonstration.
So it is because I am showing in my camera. Okay. So Divanshu, can you stop?
Yes. So again, sir, if like we can see the all the members like the gallery, so we can focus on the Gustavo sir screen. Can we see Gustavo sir camera?
But you stop sharing, and I talk and
Now.
So Divanshu, please.
So
yes, please.
So now when I say the 3, I will switch on. Okay. So
yes.
1, 2, and 3. Just focus.
Okay. So in that way, students, they can write the programs in their home, and they can test using any hardware that we have here on campus.
Okay.
Yes.
So next, I would like to call Devika ma'am.
So this is another small demonstration where now we are using these NVIDIA boards, and this is a pre-trained neural network, mobile net, and using this there was a team of students who were able to classify the object. So I have a camera here and I am putting an object in front of it, and it is able to identify the object. So, let me see whether it says it's a cell phone.
मैडम ये पेपर्स भी बीच में आ रहे हैं, एक बार पेपर्स को
I need to remove these papers. So can you see it's identifying the cell phone? And
Yes.
they have used a pre-trained network, which is mobile net. And in the same way, if I bring a textbook also here, it identifies it. And there are some 1,000 objects which it is able to identify. For example, a keyboard. So this was another kind of board which we have tried this time, and we were able to do a small project here. Thank you everyone, and this is all from our team.
Devika, can I say something? Yes. If you allow me, I would like to share that, in fact, one thing that is very important you have to know is that, of course, we have worked a lot. You cannot count how many hours we have, because we need to assist and work with the students of so many different libraries, different hardware, different sensors that we have to learn, and we have to work with them. But at the end, I think that we are having fun. It's very so it's obviously that we like this. No, I think that is something that if you are passionate about, so that's the main component is there.
And also, I would like to ask or request any student if you want to share any experience while we're working online. Okay, so Avnish, can you share some experience? Avnish is there?
Yes, sir.
Okay, so can you just share?
Yes, sir. So the online mode was like we got to learn a lot of things, but the offline mode was much better. We get the hands-on practice, and the environment with the other students was like very good, and we also got to learn a lot of things.
Thank you, Avnish. I would also like to inform that we have lab assistants Anil, Mahesh, and Ragesh ji, who are also helping us a lot, and I guess simultaneously they are also learning quite new things. So I would like to acknowledge their help also. Thank you.
Thank you, Devika ma'am and team. Any faculty would like to share their own remarks? We also have VC sir with us, Dheeraj sir.
No. I was enjoying the presentation and this Gustavo's experiment, or whatever you call it. Yeah, nothing more to add. Thank you.
We also have Sudhir sir today with us. So this is first academic forum session for Sudhir sir.
I'm extremely sorry to have joined late. There was an issue with the thing. Thank you, Sonal, for sorting out. And it was fun watching this. I enjoyed it.
Thank you so much, sir, for being with us. Naidu, sir.
Excellent work to be kept up. It was very mind-boggling, actually, like the variety of experiments which have been done. And I just note that this exercise project, I have some acquaintance in one of the reputed institutions who are doing some research on yoga, like yoga poses, how to monitor. So maybe that can be a possibility for a short internship or something like that. So these type of works open up the opportunities even for workplace, because people are more interested in practical projects, how people perform. So this is very valuable. Thank you.
Faculties would like to share anything else? I would request Sanjay sir for concluding remarks on this igniting the joy of engineering.
Are there any comments or questions from the faculty?
I have one request. I have one request from my side. I think that's very
Haji.
good to attend. I request next time from the entire admission team should attend this session.
That is what we have been saying since beginning.
So I started today. I attended first day, and really
that is
really good.
So
But next time I will make sure.
Yeah. So what you should do is, and I would request Sonal to share the recordings of the previous 5 sessions. I think we do not have the recording of the 5th one. The recording button was not put
Actually,
on. But we have the recording. Yeah. But that is why I reminded it today. Okay. I was thinking that that's a default thing, but that's not a default thing. So, but we have the recordings of the first 4 sessions, and they are very, very important for the admission team, particularly. Okay. And I'm very happy that all the colleagues have had fun watching this session today, and that justifies the name of the series, which is the joy of engineering. Joy means fun also. So perfectly fine. And so this journey that started for the humankind more than 200 years ago in 18th century, playing with electricity, and that has come to a situation where now, as in the 19th century and in the 20th century, everybody was busy putting electricity into whatever existed. So everything was getting electrified. Okay. And now this century is, because things have already been electrified, let us put some smartness in it. Let us put and use IoTs, sensors, actuators, and communication devices, etc. And make, so that is a journey that is going on, and that is why the variety is possible. But the variety that Professor Naidu mentioned, it is because so many things are there all around us, and we can put some smartness in it through these devices. And our students are equipped to put these devices into a variety of context, into a variety of objects and systems. And we hope, and that is why it is very important, this course remains open for all the departments and all the disciplines in engineering. And in fact, IoT is so important for us that even in our BCA curriculum, it is a compulsory course. And Divanshu, in this semester, to the 4th semester students of BCA, will be teaching this course on applied IoT to the BCA students, making our BCA as a very, very distinguishable program in the country. So IoT is a very strong area for our engineering institute here, and we don't just look at it as an ECE or as a computer science discipline here. We look at that mechanical engineering, civil engineering also are the application domains, for applying this area of expertise. And we hope that we will continue to do good work, combine it with our MTech programs also. A lot of IoT work going on in our MTech program also, including in our HSEE or A&R. And this area has a very good future at our university, and we will have a very good future with this with IoT. So thank you everybody for joining us today, and we hope that we come back with more sessions very soon.
Yeah, I would like to end with again a request from my side that please come forward with talks which you would like to deliver. I'll be glad to host on this platform. Thank you so much. Good day.
Thank you, sir.